Okay, so hi guys, welcome back to my channel. So this video is going to be the part 2 of Kafka. In this video, we are going to learn about why Kafka, and the next thing is we'll be understanding some of the LinkedIn problem, and the third one is we'll see the installation of Kafka. It's not the actual installation. We'll be installing, and we'll be seeing. I'll give you some commands that you can run into your desktop so that you'll get a high level idea of how Kafka works. So let's start by seeing why Kafka. Okay, so the first point is multiple producers, multiple consumers. Okay, so the Kafka is built so producers can write without any coordination, and separately many consumers or consumer groups can read the same stream independently. What it means is, it means that multiple producers and multiple consumers. So if you have watched my Meet Kafka part 1, you'll get to know that the whole point of Kafka is to decouple the producers and consumers. When producers is writing something to the topic, so it should be independent. It does not care of how many consumers are there who is going to listen this topic. So for example, order topic can be written to by 5 different microservices simultaneously. Let's say this is a topic. Okay, in next video we are going to understand deep dive into what is topic, what are partitions, very clearly, what are producers. The next video will going to be all about the producers. So let's say this is the order topic, in which all the data regarding this order will stay here. Okay, this can be written by 5 microservices, or we can say 10 microservices simultaneously and independently without knowing what all consumers are going to listen to this topic. So that is the whole point of Kafka. So the first point is multiple producers, multiple consumers. The second point is disk based retention, means messages are durably written on disk, not just held in memory until delivered. A consumer that goes down for maintenance, crashes, or just falls behind under load can resume exactly where it left off. What does this means is, disk based retention means your messages are going to be stored somewhere permanently, not temporarily, that once the message is getting delivered, then the message get lost. In the first video I have explained, I have given some examples in which the messages are getting removed once the messages are delivered to their destination. So Kafka is not like that. The third point is scalable, and the fourth point is high performance. So decoupled writers, readers, durable storage, and horizontal scaling together let Kafka sustain very high throughput and without sacrificing the sub-second latency. What do you mean by this sub-second latency? So less than 1 second between the moment a message is produced, okay, message is produced to the Kafka, and the moment the consumer is ready to consume. Okay, so within less than 1 second, this all operations are getting performed. So this is high performance. Now let's move to the LinkedIn's problem. Okay, so LinkedIn was having two separate broken systems at that time. So first one is the monitoring system. So this relied on polling with large intervals between metrics. Okay, they are built in to consume heavy metrics, and the actively tracking system. So the front end serves periodically pushes batches of messages in XML format. Okay, we'll see that in LinkedIn every activity is getting tracked. So if I say that the every activity is getting tracked, it means that someone from the front end is sharing every data that is happening on the screen to the backend. Okay, so these messages are to be sent in microseconds in very large volume. So this is the challenge that LinkedIn was having back then. Now before moving forward, let's understand what is the push and pull model. Okay, so if we see the push model, the system that has the data to send to the receiver, okay, that has the data to send to the receiver without being asked. That is the push model, means the system is pushing the data actively. Polling is nothing but the consumer side. The receiver actively goes and asks the source that do you have anything new for me, repeatedly on some interval. So this is the push and pull model. So the producer's push is, your application actively sends messages to Kafka whenever it has something to send. It is not like in some intervals I'll go and ask the producer that do you have something. It's like the producer will actively sends the data whenever it has something to send. And the consumer, a Kafka consumer, polls in a loop, actively asking its broker, give me anything new since my last offset. We'll understand what is this offset in the producer when we'll be deep diving into producers, which is nothing but in the next video. Okay, we'll understand each and everything. Now let's move forward. So LinkedIn had a huge challenge. Multiple system producing massive streams of events, means the profile update, the messages, the analytics, the logs. Okay, and multiple downstream consumers So the consumers are search indexing, recommendations, notifications, analytics. So with these huge challenges, this conflicts directly back to the phrase from the birth of Kafka. Okay, that we have already saw means the whole point of Kafka is decouple producer and consumers using a push-pull model. So now let's move to installation of Kafka. If you want to do practical in your laptop, you can run some of the commands and do some installation to see what Kafka is if you haven't worked on Kafka. Okay, so what you can do, you can install Docker desktop, you can open the terminal, okay, and you can run this command docker pull Apache Kafka latest. Okay, it downloads the Kafka image from Docker Hub to your local machine, and this Kafka image will contains all the configurations built in, so that you don't need to do tons of configurations. Okay, now start broker. Okay, what is broker? In first video I have already explained, broker is nothing but a Kafka server. Okay, so you need to start broker by running this docker command. So docker run -d, which is nothing but run that command in the background and mapping the port. So it opens a door from our machine's port 9092 to the container's port 9092. Okay, and this is the name we can give to the broker. Okay, now the fourth step is create a topic. So this is the command you need to execute in order to create a topic. In this we mention the partition, we mention the replication factor, we mention the topic name. Okay, and we mention what from where the topics configuration get pulled. Okay, so these are some command granularity that you can read and understand what this command, each and everything, what is the role of each and every keyword in this command. Now moving forward, so this is the command you need to execute in order to start a producer. Okay, so start a terminal, execute this command. Okay, now start another terminal and execute this command in order to start the consumer. Then you will be having one terminal, okay, which is nothing but the producer, one terminal which is nothing but the consumer. In producer, whatever message you will write, in consumer within fraction of seconds you will be seeing that the message are getting visible. So you can try and test this in your laptop. If you have any query regarding this, please put your queries in the comment. I'll be more than happy to answer all the queries. And then after doing all those things, you can clean up, you can execute these commands, docker stop broker and docker rm broker, in order to delete the broker which you have created. So I hope this is clear. So this is all about the Kafka part 2. And now we'll be moving to the producer config and consumer config and more about Kafka. So next video will be the detail of producer config, and I'll giving you the high level of idea of how internally it works, what are all configurations we need to do. Okay, so till then, thank you for watching and having patience. So thank you.